All right, happy Friday. Here is our notes for ellipses. So for our next conic, ellipse is going to be an oval shaped. We have the equation for our ellipse. The center is still going to be our HK, just like with our circles. And then underneath the X and underneath the Y are going to be a value. We have a squared underneath your X. That is going to be the horizontal air quote radius, the distance horizontally from the center. And then the vertical air quote radius, distance up and down from our center, is going to be our b squared. And then our ellipses always equal 1. So we have two different types of ellipse. We could have a horizontal one or a vertical one, and that is just depending on which one has a longer value. So one thing to think about is you can think of like where is the largest denominator. So if it's under X, that means it's going to be horizontal. If it's under Y, it's going to be vertical. All right. This next slide is just a bunch of lovely information. It has a definition for an ellipse. We have all sets of points, X and Y, for the curve. It's the sum of our two distances to the focal points, our foci, as a constant. So if we add the distances from the two foci, so D1 plus D2, that is going to be a constant all the way around drawing the ellipse. So if you want to check out, feel free to like Google it or go on YouTube, how to draw an ellipse. You can kind of see someone reenacting it about how to use that to actually draw it if we did it from hand. So we have two focuses, our center, and we have our main vertices that are on the major axis. We do have other vertices here that we'll graph to help us graph, but the main vertices are going to be along the longer axis. To find our foci depends on which way we do this. So for our horizontal ellipse, we do a squared minus b squared to get that distance. And then if we do a vertical ellipse, we do b squared minus a squared. Way to remember this is you want to take the bigger denominator and you're going to be subtracting the smaller. Denominator. Okay, so use that as just our definition. On the next page here, we have a ton of information. I'm not going to talk through the whole thing, so we're going to work through it. So if you need to refer back to this piece, please do. It has all of the information. So we have our horizontal and our vertical ellipse, our basic equation. Our A value is our distance from the center underneath X. So from here to here is your A value. And then the distance underneath Y is that B value from our center. We're going to use our center, we're going to use our foci, find our vertices, and we're going to do all that on some examples. So I'm going to work through task 1. So if you want to watch task 1 first and then follow along. Okay, so task 1, I have my ellipse. So things I like to look for is our A value. So we know A is going to be 5, square root of 25. And then our B value, square root of 16, is going to be 4. Our center, I'm going to pluck out our center from here. So 1, negative 2. I'm going to graph as we go here. Since A squared is bigger than C squared, A squared is bigger than B squared. To find our C value, we would use our A squared minus B squared, and then we're going to use that to find our foci. I'm going to do the vertices first. So vertices of the major axis, that's going to be the larger one. Since A is bigger, that is going to be our major axis. So I'm going to go left and right 5. 1, 2, 3, 4, 5. And that's going to be the vertices of the major axis, the larger one. So negative 4, negative 2, and 6, negative 2. For the minor axis, is going to go up and down 4 from our center. And 4. And those points are going to be 1, 2, and 1, negative 6. So back to my equation for our c squared. That is how we're going to find where the foci are located. So I'm going to plug these in. So a squared, we got 25, not plus, sorry, minus 16, and equals 9. I will say it does not often equal a nice whole number, but this one does. If it does not, leave it exact when we're writing it. So c is equal to plus or minus 3. So since the foci goes on the major axis, we're going to go left and right from our center. So I'm going to go left and right 3 to get the coordinates for our vertices, sorry, for our foci, 1, 2, 3. If it was not an exact number, say it was square root of 3 instead of just 3, plug in your calculator, get a decimal to graph, and then you would just leave it exact when we write our coordinate. All right, so we would have -2, -2, and 4, -2 as our foci. All right, I almost forgot the most important part. Don't forget to draw your ellipse. This one looks very circular-esque, but it's not a circle. That was not very good. It's just our A and our B value are very, very close together, the 5 and the 4, so it's going to make it look circle-ish. All right, go ahead and try task 2, and then come back and we will walk through it. So for task 2, I have an A value and a B value. They're the same. So it does not matter which one is which technically, but our B value is going to be 3 as well. So if you haven't figured this out, this means we actually have a circle. So if we end up with A equaling B, we end up with a circle because the radius is the same all the way around. So for our center, -3, 2. And then for the vertices of the endpoints for the major and the minor axis, these are going to be interchangeable. You just need to list all 4 of the vertices. So we're going to go left and right 3. And I'm just going to list them in that order because that's what I did first. If you didn't put them in this order, that's okay, because it doesn't matter. It's a circle. We're going to go up 3 and down 3. So I'm going to kind of continue. We got 2 and 5 and 2, -1. And then we draw our circle. Oh my gosh, these are not my best circles. There we go. And then for foci, if you're like, if I plug things in, it doesn't really work. There isn't any for a circle. So since the foci are technically both at the center, there is none to list. All right, go ahead and try the U-try. This one is going to be an ellipse, so go ahead and give it a go and pause and come back. All right, so we got our A value of 3, our B value of 2, and so A is going to be bigger than B. A squared is bigger than B squared. So let's pluck out our center. 5, -2, 1, 2, 3, 4, 5, -2. And then for A, since it's underneath the X, that means we're going left and right that amount. So left 3 and right 3. And those would be your major axis. So the coordinates for your major axis are going to be 2, -2, and 8, -2. And then our B value is underneath the Y, so we're going to go up and down 2. And that's going to get the points of our minor axis. 5, 0, and 5, -4. And then I'm going to connect my dots so I don't forget. We got an ellipse. And then for the foci, we're going to use our formula. Since A is greater than B, A squared is greater than B squared, we're going to do A squared first. 9 - 4, and that gets us 5, so square root of 5. So this is one where It's not a nice whole number, and that's fine. We're just going to plug that into our calculator to sketch where it is on our graph. So square root of 5 is about 2.3. So remember, the foci goes on the major axis, so I'm going to go left and right. 2.3. And make sure you plot those. So what I have graphed is what you should have graphed. The 4 vertices, the center, and the foci. And then I'm going to list the coordinates of our foci. Since it's an about number, we're going to use the square root of 5 to write it. You can just do a plus or minus. So we are moving left and right from the center, so we're actually changing from the x-coordinate. So you could do plus and minus root 5, and then comma -2. If you're like, I don't like putting them together, you could do 2 separate coordinates. You could do 5 plus square root of 5 and -2, and 5 minus root 5, -2. Either way is fine. You can write it kind of as a combo or separate. All right. Moving on to task 3. I'm going to point out some information, and then I want you to give it a try. So we are going to write the equation for an ellipse, and we have a major axis that is along the x-axis. So that tells me my major axis is going horizontally, and the full length of that is 14. We also have a minor axis with a length of 10. So that one I know is going up and down, and the full length of that is 10 units. Our center is at the origin, which means our coordinate is 0, 0. So using that information, try to figure out the a and the b value and put it together as an equation. Go ahead and pause and check when you're done. All right, so to find your a value, we take the full length of the major axis and we cut it in half. So a has to be 7. And then the same process for the other axis, the minor axis. Cut it in half, so b has to be 5. Then from here we have everything we need. To make our equation, we need the center and the a and the b value. So I'm going to write out a blank equation, and we're just going to plug everything in. Equals 1. So our center was 0, 0. Since a is 7, it's going underneath x, that's our horizontal distance, and b underneath y, so our vertical. And then if you needed to simplify anything, please do, which we are going to. So x squared over 49 plus y squared over 25 equals 1, and that would be your equation. All right, so task 4 and 5 are very similar, giving you some information and having you write equations. So go ahead and try both of those. A little longer of a pause, and then check them. So try both task 4 and 5. All right, so for task 4, look for the things we need. We need our center, which is 3, 0. And then we find our a value and our b value. So a, horizontal underneath our x, so 1, 2, 3, 4. And then our b value, vertical distance, is 2. And that's it. We just gotta plug it in. So I have my blank equation. Plus y over, nope, not over 2, squared equals 1. So I'm gonna plug in my center. I'm going to plug in our a value under x, because that's horizontal, and then our b value under y, because that's our vertical. And then I'm just going to simplify. We have x minus 3 squared over 16 plus y squared over 4 equals 1. All right, for task 5, we're going to write our equation. We gave us our center. And then it says our horizontal axis is the minor axis. So that's going to mean our a value is 3 underneath our x. And then the vertical has a major axis of 12. So that means our b value under y is going to be 6. You don't have to start with the blank equation. If it helps, go for it. Make sure we can know where everything needs to go. All right, so center, HK, so -2 and 3. Underneath our X is our horizontal, so 3. And then underneath the Y would be our vertical, so 6. And then I'm going to simplify anything I can, so that double negative is going to turn into a +2. And then over 9. Y minus 3 squared over 36. And then don't forget the equal 1. It's not an equation without an equal sign. All right, check those. And then we're going to go ahead and do 2 more. Go ahead and try task 6. Give it a minute, try it out, look at what you have, and see if you can work it out with your table. Actually try it, and then we'll check it. Okay, so some strategies for something like this. Look at what they give you, and you could give yourself a little sketch if that helps. It doesn't need to be super accurate. It's just a quick, hey, which way is this going, the major, minor, and things. So -2, 1, and -2, 5. Those are our foci. So that means my major axis is going to run up and down because the foci always are on our major axis. And they gave us the endpoints for that, which is these guys here. So -2, -1, -2, and 7, which makes sense. The foci are on the inside. So from here, we have a couple things. We can find the center by finding the middle between the foci. You could use a midpoint formula or kind of eyeball the in-between. Our center is going to be -2, 3. And then from here, we're going to use our major axis to get our B value. So B value is our distance from the vertice to the center. And that's going to be 4. And then we don't have the A value. That is what we are missing to write the equation. So we can use what they gave us to find the C value. C is going to be the distance from our center to the foci. So C is going to be 2. And that's what we're going to use to help us find our A value. So 2 squared equals, and 4 squared is, 4 is going to be bigger because it's on the major axis. So we're going to go 4 squared minus A squared, which is what we're going to find. So 4 equals 16. We're going to solve for A here. -12. Make that positive. Square root, and square root of 12 is A. I'm just going to leave it like square root of 12. You can simplify it, but we're going to actually just plug it into our equation, so we don't need to simplify it. All right, I'm going to start with my blank equation. X and squared, y squared over squared equals 1. Plug in our center, -2, 3. And then underneath our vertical distance, which was 4, so we're going to put 4 under the y. And then what we found for our A value is going to be the distance we go left and right from our center, so it's going to go under x. So square root of 12. All right, simplify anything that looks messy. We have x plus 2 squared, and then square root of 12 squared is just 12. That's why we didn't end up simplifying our radicals. We were just going to plug it in anyways. Y minus 3 squared over 16, and then don't forget your equals 1. And then there you go. All right, I'm going to try one more, and that is task 7. Go ahead and give it a go and then pause and come back. So looking at what it gave us, it gives us our major axis with these endpoints. So if you look that the y values are staying the same, that means the x values are changing. So that tells me this is a horizontal axis for major. So that means the whole thing is 18. So that means our A value is 9, half of that. For the minor axis, they gave us the endpoints as well, and we can notice that the x values stay the same. So it's going to be a vertical distance, and then we can look at the change from the y values. And that total is 8, which means our b value has to be 4. The other thing we need is the center. You could use your midpoint formula or in your mind kind of figure out what's halfway between either one of those sets of coordinates, because that's going to get you your midpoint, which is the center. So our center ends up being -2, 5. Or you could do a quick sketch and kind of count your boxes, whatever is quicker for you. All right, get everything set up. Equals 1, and then we're going to plug in our center. -2, 5, and then the A for 9 is going underneath our X, since that is our horizontal change. And then our B value, 4, is going to go underneath the Y squared, because that's how much we're going up and down. All right, last step, simplify everything. X plus 2 squared over 81. Y minus 5 squared over 16 equals 1, and there's your equation. All right, task 8. So I have only A and B on my slides, so I think your printed copy has 2 extra bonus questions. Feel free to do those, and then we can just go through those in class, because I forgot to put them in the slides. So at least do A and B, and then if there's time left of class, try the other 2, save your answers. We can check those first thing Tuesday. So to find the equation of ellipse in standard form, my hint to you is we are going to complete the square. So I would like you to try question A on your own or with your table. Try it out, pause, and then I'll walk through it, and then you can try question B if we need a little refresher. All right, you have your guess for question A. Step 1. For completing the square, we want to move any constant over to the other side. And then I'm going to rearrange so that my x's are next to each other. I'm going to leave a little space so I can complete the square, and then my y's are next to each other. And again, leave a little space to complete the square. To complete the square, we take half of the b value and square it so we can make it factorable. That is our goal. So we're actually going to complete the square twice. So I'm going to take half of my b value, and I'm going to square it. If you add it to one side, you must add it to the other side to keep our equation balanced. We're going to do the same thing for our y's. We're going to take half of our b value and square it, and I'm going to add the 1 to both sides. So now at this point, you have 2 things that are factorable. So we end up with x plus 4 squared, y minus 1 squared, and then you're going to add those together. That gets us 25. And for an ellipse, remember, we need it to be equal to 1. So how can we get it equal to 1? Divide by itself. So we're going to divide by 25 on both sides. And we end up with x plus 4 squared over 25. Oops. Y minus 1 squared over 25, and now it equals 1. And that would be the equation for our ellipse. Do we notice anything? We should. It's a circle. So because the A equals B, we have a circle for this one. The other ones are not circles. Surprise. So if you get something that is not if this is a circle, there would normally be a number here that you would then reduce. This one doesn't have any other than 1, so we don't have anything to reduce. So go ahead and try the next question, and then come back and check it. All right, question B. We start off the same way. We're going to move our constant to the other side and rearrange so we have all our variables next to each other that go together. My y's together. and negative 42. In order to complete the square, we need our a value to be 1. So we're going to factor out the a value from the x squared and the y squared separately. So out of the x section, I'm going to take out a 3, and I'm left with x squared minus 4x, and then I'm going to leave a little space to complete the square inside there. For the y squared, we're going to factor out the factor out the 5. We're left with y squared plus 6y, and then leave a little space to complete the square inside there. So most of this process is very similar to what we just did. We're going to take the half of our b value, square it, and add it to both sides. But I'm not actually adding 4. What I'm really adding is the 3 times 4, which is 12. Okay, because that 3 on the outside of the parentheses. Half of our b value for the y's, square it, and I'm again not adding 9, I'm really adding 45 because of the 5 on the outside. Now we have the inside of those parentheses that are factorable. We have 3x minus 2 squared, 5y plus 3 squared. Add all that up together, we get 15. And then our last step is to make this equal 1. So kind of now you see what I was talking about with the last one where we didn't have anything to reduce down, so it ended up being a circle. We have 3 over 15 and 5 over 15, which we're going to reduce to make it in standard form. So I end up with x minus 2 squared over 5 plus y plus 3 squared over 3 equals 1. And there you go. There's your ellipse. And like I said, I know there were 2 extra questions on the printed paper. If you kind of mainly followed along with A and B, try the other 2, and I will see where I put them, and we can go over those on Tuesday. Otherwise, you have homework. I'll check off on Tuesday as well. And keep that in mind and have a nice weekend.